Customer data is something that is important to most of us. We get data from many sources, many different types. Today I'll be talking most about customer data and how to clean it. It never seems to come to us in a great shape, and so we often have to work with it. Customer data can be something like sales records, responses to marketing attempts, contact information. But the data is always messy. Never assume that it's going to be clean. There's going to be incorrect data in it where someone misunderstood what you wanted. They couldn't type it in correctly. They misread when the data entry was looking at it. There's missing data because someone just didn't bother filling in a field. There's formatting issues. They use lowercase and you expected uppercase in the database. Reasons for messy data. Sometimes it's the supervisors not giving enough oversight or instructions to the employees. Sometimes it's the employee's fault because they don't have the proper equipment. The database application is out of date. For example, at Parks and Wildlife, where I'm at, our greatest vendor or biggest vendor is Walmart. Walmart clerks don't really care about Parks and Wildlife. They're just there to sell their stuff. So when they need to enter customer data into the sales database when they sell a hunting license for us, it may or may not be any good quality. They say that an infinite number of monkeys on an infinite number of typewriters could produce Hamlet. I don't get the good monkey on my data entry. No one ever went broke underestimating the intelligence of the American public. Basically, you assume that you have idiots on the other end, and you need to code proactively to correct all of the mistakes that you know are going to happen eventually. How messy can data be? Well, I've got a data set of license sales. There's about 12 million people in it. We have different suffixes. Gender, you would expect male or female, but we have multiple cases. Sometimes they enter a U. I assume that's for unknown. There's also a T. That's probably just a typo. There could be other things. I've got other databases that use 0 and 1. What a 2 is in that database, no one knows. The date of birth. It should be, relatively recent, within 100 years or so, you would think. I've got my databases, birth dates going back to 1776, and we occasionally get them into the future. There are only 50 states, District of Columbia, and then 12 territories. How do we get 487 different states in the driver's license? Well, that's mainly because people are tabbing too fast and they put part of the zip code into the driver's license state or some other thing like that. We have in the addresses 359 states, probably the same ones, just a subset of the driver's license states, same mistakes are being made. Foreign states, there's 200-ish states. There are 200 so countries in the world. My database has 3,633 different countries. That's because they think country and county is the same thing. Foreign states, well, how many different ways do you write Alberta, Canada, or Sinaloa, Mexico? And don't even try to ask people to know how to do foreign states in Germany or the United Kingdom. It's gonna be screwed up. Well, when you get your data, just assume that you've never looked at it before, because there's going to be chances that even if you did look at it a month before, new mistakes are going to have been made in any large system. So a really good idea when you're starting a project is to go through and take a deep look at the actual structure of the database before you even look at the data itself. Sometimes there's documentation, but oftentimes there's none at all. You're going to have to create your own, figure out what the data set is. There's a really good chance you've not been associated with this project at all until they just drop it in your lap. So go find out what it is. When the documentation does exist, I bet it's incomplete, they forgot to add something, or it's 25 years out of date. When you get done with the documentation looking through it, create your own, put it in your project files so it'll be there for later on. A good way to get the data structure is just do a proc contents. By doing that, you get a list of every field that is in the table and every table that's in the database. If you do the varnum, that will give you the list of variables in order of the database rather than alphabetical, which is the default. You could use proc contents or proc datasets for this. The only difference is the library reference that is the default. So they give you the same thing. Once you look at the data, you can start seeing that there's going to be confusing variable names. Resident state, is that yes or no for their resident in the state? Or is that the name of the state, the abbreviation of the state, or a number code for the state? You can't tell until you look at the data. What data is in each field? You just got to look at it and find out what's there. The data fields are not always used as intended. I've got a database where there's a location field, but it's often not used. Data entry have started using that as a notes and comments field. So when we try to match up locations, we get comments like must have written permission. That's not a good location. So that's a data entry error, but it's in the data, you got to work with it. When you're looking through the data, is it unexpected, but it could be correct? Is it an outlier? So it's really rare, but you got to accept it just in case. Or is it an error? Then you need to correct it. Good way to look at that is proc frequency. With that, you can get a very quick frequency count and percent of every variable in a table. So my first example there is going to give you every variable in the test data set. The second one is only going to look at the birth date and the gender and give you tables for those. The third one is not going to print it to the screen, but it will create temporary data sets that you can then do further manipulation for. Proc means will give you some of that, but it will also give you the mean, mode, median, and other variables, and it gives it in a nice compact fashion that can be very useful. It also gives you the min and max, which the frequency does, but it's just nice here too. It just depends on what you need. So the first one on this example, class gender var age, is going to give you the median age, the mean age, confidence intervals for everyone, and then for each gender. The second one is only going to give the average grade, the confidence interval, the mean and min, max, for grade by gender and by school year, but it's not going to give it for all, and it's not going to break it down gender, grade, or school year grade. Proc univariate is going to be quite similar to the previous two. It gives a lot of the same thing, but it's also going to give you analysis of normality of the data. You can do quartiles, frequency plots, and other things. This example tells it to do the analysis for age, height, and weight, and then do it by gender, but only produce histograms for age. So, you just go through, figure out exactly what you need. These examples are showing what you can do, not necessarily the way everyone would do it. But there's data steps, the procedures. You also have SQL that you can use. Whether you use SQL or a proc step basically depends on what you're more comfortable with. They can get the same thing. Sometimes one is better, sometimes the other is better. It's just whatever you prefer. I've given examples here as well. First one, you create a table. It's going to have the birth date and then the count of the birth date. So it's just a frequency, just like proc frequency. You have it there. It will give the table, but it's not going to show it on the screen. So if you wanted to have that, you would do a proc print afterwards, or you would open the data set itself. The second one is basically doing a proc means. You're getting a count, a mean, a min, a max, and stuff of the gender and ages. So you can get the same things, just whichever way you prefer. Once you know what your data is, you're going to have to clean it. There are always going to be errors. It doesn't matter what your data, if you've got more than 10 records, just assume that one of them is going to have an error in it somewhere. Bad data is often worse than no data at all. If you're getting the incorrect answers, that could lead to very bad results down the line. So you want to try to fix as many errors as you can. Fix all the common ones, eliminate the bad data, and standardize data as much as possible. Standardizing the data is important because you want to have Texas, TX. Make sure it's not TE. Make sure it's not capital T, small x. Proc frequency is case sensitive. If you do it without fixing that first, you're going to have a listing for capital T, capital X, capital T, small x, and then small t, small x. And then you would have to combine them later on. It just makes more work for you. Clean it first so you don't have to worry about it. When you're going through the addresses, and addresses are going to be messy because there's so many different ways to write them, it's just a good idea to try to standardize it. The post office really likes certain abbreviations to be used. They also like having them capitalized all the way through because it's easier for the recognition software to read. Now you could use abbreviations or words, they will accept either, and there's reasons to use either one. If you correct a lot of this stuff, it improves your delivery rate, which is always important. If you're going to spend the money on postage, you just as well try to get it there. Sometimes you want to use abbreviations because it's less database space and memory. That can be important at times, other times it's not so important. Printing labels, though, I find there's often a space limitation on it, and just to make long addresses shorter can be quite helpful there. And I found that it's much easier to change a word to an abbreviation than the other way around. If you see Ranch Road, you can be pretty sure that that's okay to abbreviate it RR. If you see RR somewhere in an address, you don't know automatically that that is need to be changed to Ranch Road. So one way is easy, the other is not. Data cleansing, here's one that I often need to do, just mention. Address, transstring, address, state highway, SH. That's telling it to look anywhere it sees state highway, replace it with SH. There are two different functions that you can use for this, transstring and tranword, TRANWRD. Do the same thing, the one with string at the end, that one can return a zero length field. So it's these examples, it wouldn't matter what you use. It would if you wanted to have it remove letters rather than just replace the letters. Country names. Often the county is entered instead of the country. We find that a lot where people just read it too fast and go through. There are 241 countries according to the UN. The US recognizes 195 of those. In my database, I have found 46 different ways of entering the United States. Mexico and Canada probably double that. And that's because people don't understand. And they see county or country. They don't know where to put the foreign state, the foreign postal code. They just don't understand the other systems in use, and they're going to screw it up. The correct way to do it would be to have a drop-down list, of course. But just because you're the data analyst doesn't mean you get to influence the data entry application, which often might have been created 20, 25 years ago. So you have to clean it. Well, here's what I use to clean country names in my database when I need to do a frequency distribution to find out where our license sales are coming from. So if country is in America, 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 3 different ways of spelling it, all incorrect. So go through all of these, correct them. 97, 98% of all of our license sales are from the US. So do that first and then check. A lot of times you would write the code in alphabetical, so Albania would be first and something else, and Belarusia. Well, do US first because that catches almost all of them, and then you can go through. Just to do the other countries in the world is another 300 lines of code. If you really want to see all 300 lines, contact me. I'd be happy to send it to you. I don't have it here. Another cleanup, since county and country are often confused, just do an update of that. If the country is USA, or no, if country is not USA, then you would want to set it to USA and the state to Texas if the country is actually a county name from Texas. So if the country is Dallas or Houston, that's a pretty good indication that they just misread it, and we can correct that data quite easily. Now, 95% of my data is from Texas. So I can be pretty confident that something like, let's say, Johnson County is in Texas. But if you have sales from all across the United States, you cannot be sure, and there might be 5 different Johnson counties or Smith counties or something in the United States, and you cannot use this to correct it. But for certain cases, this can work quite well. Another one that we see is they type the state code or the state name into the country because they've hit tab too many times is really what's happening. So if you find a good state code in the country, go ahead and change it. Same thing with the state name. If it says country is equal to Texas, it's USA. Go ahead and just correct it for them. Email addresses. This is a big one. No one likes spam. And the only sure way to know whether the email is good is to send an email to it. But you don't want to do that if your database has 12 million emails in it already. You're going to do a sample of them at times for marketing or whatever else. So there's ways to check beforehand so that you can get rid of bad ones so you don't even have to worry about them anymore. Regular expressions, for those that use them, is the easiest and the best way to do this. But they can go completely overboard. Basics are usually good enough. To do well, I'll show you here. For email addresses, here's some ways to correct it. First line there, data test set test. Well, email compress. That is telling it to get rid of all spaces. You can actually have a space in an email address under certain conditions, but it's extremely rare because a lot of internet providers won't allow it. So it's more likely to be a typo than correct. So I go ahead and remove spaces just at the very start. And that can also get rid of the trailing and leading spaces, which are an issue at times too. The second line takes all double dots and replaces it with a single dot. You can't have a double dot in an email, so it's got to be incorrect anyway. By replacing it with one dot, maybe that corrects it. If you cannot have a dot at the start or at the end of an email address, so you just as well take those off too. If you want to get really detailed, if there's a dot at the end, you would maybe look before that dot and see if it's the word Yahoo, Hotmail, AT&T, some of the really big ISPs, because people will put in John@Yahoo as their email address. Well, you can correct that by putting on .com. You can't do this for very many types of emails, but for the big ones, AOL, Yahoo, Hotmail, a couple others, it's worth trying. An email address has to be at least 6 characters. If it's under 6 characters, it's automatically bad. Just well get rid of it. In reality, 8 probably is a better number, but 6 is possible under certain systems. A@b.us is a legal address if you have the B domain name, which probably doesn't happen, but it is a legal one. So my regular expression, the PRX match there, goes through, test it to find out if it's a letter, then at, another letter, a dot, and then at least two more letters. And if it doesn't fit that minimal matching, then it says it's a bad email and it'll reset it to null for me. There's better ones, like I mentioned. There's some out on the web that you can look for. There's a link in my paper to get everything, absolutely everything in the world that could possibly be a match. It's 6,500 characters for the regular expression. There's probably no need to ever go into that detail. One of the big problems I find is that database fields have been padded. For some reason, they've typed in a space at the end of a name, space at the start. Some database fields might be set up so that if it's 8 characters and you only type in 6, it automatically puts 2 more spaces at the end so that everything in that field is 8 characters. That's a database issue. You're probably not going to be able to fix it, so go ahead and get rid of the spaces. There are people that will put in spaces instead of just leaving a field blank. Don't know why, it happens though. So to get rid of those, you can do trim in. There's trim and trim in. You can do one of those after setting it left first. That gets rid of all of the trailing spaces. Or you can just do a strip. That is the same thing as doing a trim left. Strip actually takes less time. It's a newer command. If you've got a really old version of SAS, you might not have strip as a function in it. Address, comp BL, that's telling it to remove all double spaces. Now, you could have, say, 3 spaces in a row or 4 spaces in a row. It will take any number of spaces and reduce it down to 1. With city, I've done the trans word and said if you look and find 2 spaces, replace it with just 1. That works if you know that there can never be more than 2 spaces, because if it finds 4 spaces, it's going to replace it with 2 single spaces, so you're still going to have an error. If you think you could have multiple spaces in a row, the comp BL is better to use. For email, like I mentioned earlier, spaces are almost always wrong, so just go ahead and get rid of them there too. The post office prefers that uppercase be used on mailing labels. So if you're creating mailing labels, you just as well go ahead and capitalize it to make them happy. It just makes mailing a little bit easier. And using a standardized case means fewer comparisons and better reporting when you're doing your data analysis anyway. When to capitalize a letter? Well, there's a bunch of different styles and manuals that say do it this way, do it that way. The US printing, I can't remember the exact name of it, US print shop basically, they say use a and the, at, by, for, in, of, on, to, up, and, as, but, it, or, and nor. Those are the ones that you don't capitalize in a document or publication. Everything else does get it. That's just their rules. It's probably a good common one just to default to if you're not given a standard otherwise. So to correct the cases, uppercase and lowercase is the basic ones. Prop case will capitalize the first word, the first letter of each word. In mine, I've told it to do it after a space, a dash, or an apostrophe. So that gets the first letter of each word, but also will correct for O'Keefe, O apostrophe Keefe, or Warnes dash Haney, the names like that. It will not correct for McDonald. Matter of fact, it will make it wrong. So it's capital M, AC, and it's got a small d. You would have to do extra coding to get the capital D in a McDonald. So it doesn't get everything. Country, If you're wanting to correct it, you could do prop case country. It capitalizes the first letter of every word. However, there are a couple countries, Trinidad and Tobago would be one, where and is part of the country name. You would want that lowercase, so you would actually need 2 lines to correct country for incorrect cases. Invalid characters, you're going to see this a lot. Most of the time, the biggest one I find is 0 and O being incorrectly used. So in a name, you want the O. In zip codes, you want the 0. You just need to replace them. State, it doesn't matter if it's a name or an abbreviation, it should be all letters. So you can use the compress function to remove anything that is not a basic letter. Note that I don't have 0 in there on state. M0 is probably MO for Missouri. So you would actually want to correct that first. Or creating new fields. You've got the data, you've cleaned a lot of data, but that doesn't mean that you have all of the data that you need. If you can calculate a field, there's no need to keep it in the database. Keep the database small. So you're going to be creating new fields on the fly. For me, I do lots of surveys. Same thing with marketing work. You don't want to ask a customer info unless you really need it, and you want to ask them as little as possible. So if you have the birth date already, don't ask them their age. If you have zip code, you might not need to ask what county they live in. You can look that up. If you have data already, don't ask it again. Make it simple for them. But the data that you do have might not be in the format that you need, and you might need to bin existing data. So you've got age, but what you really need is whether they're an adult or a kid for something, because you're not going to send the kids any marketing. Now you could just say if they're under 18 years of age, but maybe you need to actually do a frequency count first to tell people that 81% of your database is adults and 19% kids. So you'd want to bin it. You might need to modify the database or an app, but that's usually not an option. For any big data set, you can assume that it's going to be a big company, which means that you're going to have separate people doing each of these functions. So you're going to have to do it on the fly. You can't get it corrected at the raw data level. Age. Here's a very common one. You get birth date. You need to correct it first. If birth date is in the future, you know it's bad. Go ahead and just reset it to null. If the birth date was before January 1st, 1900, which is my standard cutoff right now, you say, well, that's a 120-year-old person, but well, some of my license sales goes back to 1972, so I have to be a little bit careful with it. So choose your dates, then reset to null if you know it just can't be possible outside of that. If you have a number, then you can then calculate the age. Using the year diff function, you can easily calculate the birth date from today or from purchase date or any other time period. Birth year, you can also calculate in a very similar way. Now, we've got here, if age is 0, if 0 is less than or equal to age, which is less than or equal to 17, well, we use 17 as a cutoff for juveniles. You might need 18 or 21, depending on what you're doing on your project. We have to accept 0 as an age because we actually have people buying a lifetime hunting license when they're 2 days old. This happens a couple times a year. It's actually grandparents who, as soon as the kid is born, go out and get a hunting and fishing license for the grandchild. So I have to accept age 0. For the age decade, many times you're wanting to bin the data. For this, I use it for age stratification, for analysis and other things, along with just letting Management know that we have this percentage of people that are 25 to 34. That can be interesting at times. So go through, figure out what the decades are. You might need to use 0 to 10, 10 to 20, something simpler. We use this one because anything under 17 is automatically in one group for us, and then we just kind of go up 10 years at a time from then. Another one that is very commonly seen is the generation. Are they a baby boomer? Generation X, millennial? Well, here's one set of years that I have found that is commonly accepted as the start and end dates for the different generations. If you look, you'll find different ones. Just decide which ones you like and stick with those. You'll see that I have here 1 dot greatest, 2 dot silent, 3 dot baby boomer. That is so when I do a proc frequency later on, it will put them in order that I want them there. Otherwise, it would automatically do it by alphabetical, and then I'd have to rearrange when I did my report. This just makes it a little bit simpler for me. Another thing that is very common, that I find at least, is finding out how far people are away from something. So for me, it could be how far they traveled to hunt or to go to a state park or from a boat dock that they used. It might be that you want to know how far they are away from the store that they shopped at. There's several different ways to do this within SAS. The easy way is to use the sashelp.zip code table that comes with SAS installations. Is automatically there. Everyone has it. With that table, every zip code has one record, and it says which county, city, state that they're in, and gives information on the latitude and longitude of the center of the zip code, along with other pieces of information. It's not perfect. There's only one record per zip code. Zip codes can cross county and state lines. So depending on your use, it's, let's say, 95% accurate. Is that good enough? You'll have to judge. For me, for this, it's pretty good. So I've taken a data set and I find out what their residence is. That's the zip code, and I'm getting the XY based off of that. And then I do the same thing for a park, and I know what the zip code of the park office is, so I can get the X and Y of it. And then using that, I can find the geodetic distance, which is a very accurate distance along the surface of the Earth from 2 points of latitude and longitude. Now, the DM on the end says that I am entering it in degrees and that I want miles. You can also use radians and get it out in kilometers. Zip distance, if you don't have the lat long, you just have the zips, it will actually do the lookup for you. So zip city distance, it's made to do between two different cities, but just plug in your two zip codes, it'll tell you how far apart they are from the center of zip to center of zip. Geodetic distance is more accurate because it's going from lat long. Now, if you're using zip code to look up lat long, you just will use zip distance to start with. But if you actually have points, someone went out with Garmin or a Trimble and got the exact GPS point of the entrance to the park, that's better. You would want to use the geodetic distance. These are in the newer versions of SAS. If you have an old version, they're not there. You're going to have to calculate it yourself. The Great Circle formula can be done. There's variations on it, many of them. Look it up on the web. My paper has one variation of it that will let you calculate it. It's accurate to within 0.5%. And that's because the Earth is not a perfect sphere. It is a slightly flattened one. And the geodetic difference will correct for that, but the older Great Circle formula does not. For most purposes, it's good enough. You just need to know how accurate do you need the distance between them. Full and reverse names. If you've got a good data set, you're going to have salutation, first name, middle name, last name, and suffix in different fields. Well, if you're combining them, say for a mail merge to print onto a label, you're going to want to combine them. SAS has a bunch of different functions that lets you concatenate fields. There's the concatenate operator, which is the double bars, but there's also cat, cat-s, cat-x, and several others. They differ on how they handle trailing and leading spaces, as well as whether they put in a delimiter or not. Cat-x puts in a delimiter, so for full name equal cat-x, it's going to put a space in between first name and last name. If I want to do last name first, so Purvis, comma, space, Jon, space, Ray, last name first is often useful for other things. So for that, you don't want to insert the space. It's better to go ahead and just use the concatenate operator or the cat function and create it yourself in the way that I've done there. And so here's the code where if you have the middle name or not, and whether you have a suffix or not, you can create those. Metropolitan statistical area. That is something that the Census Bureau uses. It is based on the county level. So the entire county is considered either a rural county or a metro county. It's based on areas that have population of at least 50,000 in the surrounding area. So if you do this, you're not looking at whether I'm living in a rural or urban environment. You're looking at whether I live in a rural or urban county by their definition. The sashelp.zip code table, which I mentioned earlier, has a field in it, MSA. That is the number. It's just a code, 4 digits as I remember, that's going to give you the metropolitan statistical area. It does not have the name of it, so it's not the Austin, Round Rock, New Braunfels metropolitan statistical area. It's 640. And you'll have to go onto the web or contact me. I've got the list of them to get the actual name for each one. But often you're wanting to know where the person is near. So I want to know all of the license sales in the Dallas area, the Houston area, and the San Antonio area. I could try and get a list of zip codes and put them all together and use if-then statements or merges or whatever to figure it out. It's easier just to use the metropolitan statistical area. We have the MSA because it comes in the SASHelp, just as well use it. Within that, if it's 0, that means it's a rural county. So all rural counties in the US, it doesn't matter where, just automatically under 0. Everything else has a number and tells you where they are. That's it for the data cleaning that I do. There's a lot more out there. Here's just some basics to get you started. The paper that's associated with this presentation, the link is at the bottom there. Feel free to download it, take a read of it. Contact me if you have any questions. Thanks.